All right, it's coming through for me.
All right, I'll kick off.
Mm-hmm.
First of all, thank you again for joining back the Public City Office Hour. And today we're going to talk about an interesting open source project called Loopback. And Loopback is the framework that serves as an engine that propels the Collab.Land backend. So I'm going to give a quick pitch on Collab.Land itself, and then try to see how Loopback fit into the overall picture as a foundational system component. Right. And first, to give you a little bit high-level overview of the Collab.Land backend. And over the 3 years, we have grown so much, and we have to build our sophisticated backend to support the skill we are serving, thousands of tokenized communities and the millions of members. Whatever you do from Discord, from Telegram that utilize the Collab.Land bot, it will be automatically handled by the Collab.Land backend. No matter if that's a Let's Go flow or some background check or some of the mini apps, they're all coming back to the Collab.Land backend. So logically speaking, now we deploy the Collab.Land backend as a bunch of microservices as separate type of servers on cloud environment like AWS or GCP. And to name a few critical servers, so first of all, we have the API server. So the API server exposes the REST API endpoints that accept APIs from different clients. Second part is so-called job servers, because some of the operations will take longer to deliver. So that's why we need to have some background processing, in a separate server. And we kind of isolate the server pool into 3 different buckets. One is for the join server, which handles the user interactions, such as a Let's Go flow. The second bucket is a background server, because we periodically run the balance check for each of the member in the community to make sure the digital ownership still qualify them in the corresponding membership, such as the Discord roles or Telegram group members. Third bucket is called events. So we optimize the system in such a way we basing on the blockchain events, especially the asset transfer events for the different ERC tokens. Then upon this event, we figure out if we have to revalidate a community member for the membership qualifications. Okay, so that's an event background check. We also have 2 other dedicated servers. One is called cron server, which is our scheduling server that iterates through all the communities and schedule the community for the background check. We also have a dedicated server talking to Discord, because we have to watch the Discord event to handle certain things, such as the community invite the bot, kick out the bot, or the member trigger some events, such as the anti-scamming feature that we watch the name change so that we prevent the hackers to reuse the Collab.Land's official name to trap the users. Okay? So the Discord server makes a WebSocket connection to the Discord backend and watch all the events. And between the different servers we mentioned in the past, we use a queuing system or a messaging system to communicate. So for example, the API server can take a request and drop the request into the job server to process. Okay? Or the cron server schedule a community background check into the job server. And also the Discord server receives certain events and maybe drop events into the queue so that the job server can pick them up and process in the background. So those are a little bit really, really high level structure of the Collab.Land backend. Then diving into the code base and the implementation side, it's really amazing like how much stuff we built over the years. So now we have one single mono repo to contain all the source code for the Collab.Land backend. And in that mono repo, we are seeing almost 100 npm package. So that means we have about 100 npm package that get composed together to function as a Collab.Land backend that deal with a different processing, right? And I want to show that to you as well. So we have this model repo, and this model repo actually it's being managed by a tool called Nina. So Nina is a good tool that helps you to organize the code base with so many moving parts into one GitHub repo. And if you look at here, we have all these different npm packages, and some of them are public, some of them are private, but altogether we already have 99 packages, right? So that gives you some signal like how complex, how many integrations we have done for the Collab.Land backend. And that kind of justify Collab.Land as a very large scale project. And in that project, we have a lot of different things for the different purpose, especially when it comes to our capability to integrate with so many different wallet types, with so many different blockchain types, and also there's so many different ways to provide token gating, right? So to really maintain and develop such a large scale project, you really need to have some discipline and possibly get some help from a good framework. That's where like we see the connection. Right? You sort of have to make sure you meaningfully manage so many in progress development from different areas, and how do you keep that modular? Because otherwise, imagine now we have 99 modules, and imagine you only have 4 to 5 different modules to contain this code. It's really hard to imagine how we'll deal with that spaghetti code, right? So the isolate modularity is definitely a critical requirement. And of course, like between these different modules, the dependencies, right? For example, we have Redis as a backend registry, and we have a Redis queue that utilize the Redis service. And we have many other services that depend on the Redis connectivity, right? And how do we make sure the dependency are being explicitly managed at the runtime level beyond just the npm module dependencies? So that's a very interesting challenge to handle large scale project that requires these different tiers of integrations. So another critical requirement is you really want to keep the platform extensible, right? Because Collab.Land is in a place to serve the needs of the tokenized communities, and each community have their unique requirement. Some community use ERC20 token on mainnet. Some community use NFT on Polygon. Some community use MetaMask as a wallet. Some community use OpenSea. Some community wants to handle Solana. So there are many different pieces that require our runtime to be extensible, especially with the introduction of the marketplace. Then we allow third-party apps to build mini apps on top of our platform, right? So these mini apps are basically just external extensions to the Collab.Land runtime, and having the extensibility being part of the base framework is critical, right? So those kind of justify, for any given large scale project, how do you meaningfully manage the development and have a very powerful runtime that drives the modularity, the dependency management, and the extensibility as a critical fact to be successful. So then I kind of going back to, hey, why we choose Loopback to start with. First of all, there's a little personal preference because I co-created Loopback almost like 10 years ago in April of 2013, where I was a co-founder at a startup called Strong Loop. And Strong Loop was trying to really bring the Node.js platform to the mainstream adoption. And we try to find the best use case for the platform. And we realized, the API platform, it's a perfect use case for Node.js because first of all, Node.js is in JavaScript, right? And most of the API consumer coming from the website. And the website is mostly written in JavaScript, use JSON as a data, representation, right? So having the same technology on the backend, that definitely lower the barrier for non-savvy backend developers to create APIs. And secondly, is Node.js is really good at I/O intensive work, right? And most of the API interaction is through the network. So that's a perfect, especially say, look up the records from the database, talking to another service through REST API or RPC. So that's where we decide to build a new framework with Node.js as a platform and using JavaScript as a primary language. And in the past, there were stuff like Spring, which is a Java framework, right? Then before Loopback, there was Express, but Express is a very minimal framework that allows you to easily handle the HTTP request and response, but it does not give you any high-level abstraction that helps you to build APIs and microservices. So that's why we create this Loopback framework about 10 years ago as StrongLoop, right? Then in 2015, StrongLoop was acquired by IBM. I continued my journey with IBM, and I was lucky to continuously have the sponsorship from IBM to continue to work on the Loopback project. And we learned a lot of lessons in building the first three versions of Loopback. So the first three versions of Loopback is mostly, using JavaScript, plain JavaScript, and we also use a couple repos to maintain the code. Then we realized moving forward, it becomes so difficult to maintain that string because for plain JavaScript, there's a lot of hidden knowledge in the JavaScript code, right? And there's no type checking, no stuff like that. Then very much whoever have been working on the code base has the insights. But for newcomers, it's very difficult for them to understand everything and be productive in contributing to that code base. And secondly, Loopback version 1 to 3 is very much convention driven. It makes it easy for you to get started to create API that talk to existing databases or services. So you don't have to think twice. And we develop a bunch of COIs to make it really easy for you to define API, even as a front-end developer, right? But moving into a more complex project, then you often feel you need to have the ability and the flexibility to customize the framework, right? And that kind of creates this new demand. We need to create a second generation of Loopback, and that's why we kind of rewrite the code base from the beginning to use TypeScript, use monorepo, and adopt a few critical design patterns to make the Loopback 4 really suitable for larger scale project. So I'm going to mention that a little bit later. Now, there were a couple of milestones we have achieved. So back in October 2019, the framework was rewarded by API Award as the best API middleware of the year. Right? And then in April of 2022, IBM donates the open source project to OpenJS Foundation. And we graduate into the OpenJS Foundation as a large project. So basically, it's an official project on the OpenJS Foundation. And if you don't know OpenJS Foundation, it's a merge between the Node.js Foundation and the JavaScript Foundation, and it maintains a lot of popular JavaScript projects such as Express, Loopback, jQuery, Festify. So there are a lot of things around that. So that being said, I want to go back to Loopback and give you a quick flight. So you kind of understand what's the motivation behind Loopback and what's the benefit of using Loopback, right? So I'm going to just switch to a live mode, and I'm going to use the Loopback documentation. to walk you through some of the insights. So first of all, we have this website called Loopback.io, right? It's fairly straightforward. And we summarize Loopback 4 as a highly extensible Node.js and the TypeScript framework for building APIs and microservices. And we have two streams of the code base. So this stream was end of life, which is from version 1 to version 3. It's plain JavaScript based. And we're getting 13, thousand GitHub stars. Then the Loopback 4 stream is a stream we actively maintain, and it's approaching 5,000 stars. And since we have a lot of different modules behind the scenes, and sometimes the stuff are not fully aggregated because usually we only look at the facade repo, right? And if you are interested, you can also check out the npm download status of Loopback 4. You will see millions of downloads every single year. Usually I can go to a place like npm stats, so you can check out the status of open source project that give you the confidence. So for example, let's do a quick run here, right? So we can say, let's look at one of the core Loopback modules we have, and let's show the chart here. So if you look at this particular module, this is a downloads per day. So we are hitting about like 10,000 downloads every single day. And week-wise, we're seeing 50K downloads per week. Then month-wise, we're seeing like 200K. Then this is a whole year. So if you look at the last year from August 15 to today, it's about 2 million downloads for the whole year, right? So it still stay as a very popular open source project for so many years. And I'm proud of part of that team that creates and maintain that project. And what's even better is now I can use the framework for Collab.Land that extend the capability of Loopback to support Web3 development. Right? So getting into the woods a little bit, and I want to get into the documentation side and show a couple of things that give you a high-level overview. Right? Really, this high-level diagram shows why we need to create Loopback, right? And we serve different developer personas. It's a developer framework. So we serve the API developers, and we also serve the platform developers. So as part of the rewrite of Loopback 4, we create a mini core for Loopback. That means if you are now working on the REST API, if you only build like a JavaScript or not TypeScript with Node.js, you can actually use the core, and the core give you all the composability and the extensibility you need to grow your platform. So that tiered approach give us this possibility to support different developer personas. So we have API developer, we have platform developer. Then you could have becoming a so-called extension developer, because Loopback itself is very extensible. It allows you to plug in different pieces of logic to integrate with the different things, right? Say you want to talk to different kind of service, you need to talk to different kind of database, you want to hook up with GraphQL, you want to add a different metric. Those things will be coming as an extension. Then we build COI tooling and some UI tooling around that, so that make it easy for you to work on the different use cases. But toward the end, you will get a bunch of API endpoints, or you have a platform running on top of Loopback, right? Then for the backend integration, is really talking to the different security layer, storage layer, or talking to existing services, or integrate with the different kind of data stores, right? So this is really the high-level pitch of a Loopback, design principle. Then another thing I want to show you is what's a typical Loopback application, right? So for here, we use the online shopping as a simple use case, right? Then this is a little bit high level description of this shopping application. Then you have different services such as a shopping cart, or history, user management. Then you have different backend to do the shopping cart maintenance. Then you use the MongoDB to store the all history. Then you have an AI engine to do the product recommendation. Right. So the left side you will get a bunch of REST API. On the right side you get a lot of infrastructure and the database integration. Right. Then Loopback creates some, separation of concerns. Okay, so that's where we guide the developers to think about this whole diagram in different tiers. So that's why here we talk about for the API endpoints, we are going to have so-called a controller tier. So controller tier basically maps the business logic to the REST API endpoint, and potentially map to the GraphQL endpoint, right? Then toward the end, you will see a bunch of open API specification, and we also have this so-called API Explorer to surface that. So for example, if I go to our API Explorer, which is the one we use for Collab.Land itself, and this is the visualization or the playground for the different APIs, so all the different kind of controllers, right? So that's where, the first tier, the user-facing tier, it's really the API endpoints, and that's mostly modeled as a controller. Then, along with the controller, we have authentication and authorization, and of course, the controller need to interact with the core business logic. So as I mentioned, we have things like, system level service like a JW token or password hasher, or application level service such as product recommendation, right? So the controller takes the API request and invoke the services. Then, whenever the response is produced by the services, we translate the service response into a REST API response as well, right? Service encapsulates the core business logic, but for certain services, they need to deal with the database or data storage access. So that's where we say, hey, we need to have a data model. So we model the domain as users, as orders, as shopping cart, as product. Right? Then we create a so-called entity layer, which is a so-called repository layer that allows you to use a different data store to do cross operations against the different data models, because toward the end, some API will be just a translation of the database access using the data models we have. And the data model will be find its surface as a JSON schema to the REST API and becoming a database schema for your relational database, right? So this is a typical loopback application, and that kind of give you a little bit high level idea how these things could be glued together by the framework. Then inside the application, we have to deal with things like dependency. So for example, the user controller has a dependency on a couple other things, like it need to invoke the password hasher, it need to talk to the user repository, right? And Loopback creates a meaningful dependency injection to help you manage these dependencies, instead of you have to understand that dependency hierarchy and maintain that chain of dependencies, right? Then we also showcase, it's a model-driven design. You can define the different data models, then the models could be mapped to the REST tier, could be mapped to the database tier, right? So those are the key concepts coming from Loopback. Then another thing I want to quickly show you is the different concepts we have. So this is a very busy diagram to show what's a typical abstraction of the Loopback application. So first of all, you have a client, API client, talking to a Loopback application, and Loopback application surface a server environment for the REST API, for HTTP2 API, for GraphQL API. Then we have a middleware tier that comes between the request and the request handling. So you could have some global middleware being added to this tier so that you can deal with security, you can deal with rate limiting, you can deal with metrics tracking, right? And then finally, the HTTP request will be translated into a JavaScript function call hosted by the controller. Then the controller need to figure out how to find the downstream pieces to do the processing. And of course, between these different artifacts, you can also have interceptors to help you manage the cross-cutting concerns. For example, the authorization can come into here, and you can have a role-based authorization between the REST tier to the business logic tier, so that you can say, oh, this is an API, this is a resource, then whoever is calling this API through the authentication tier, we understand which application is making that call and which user is making that call, right? So this tier will help us do that kind of stuff. Then finding the downstream, it could be talking to a database using the data model, or you could talk to a service, and that service probably will route your service to another cloud service. Then you could have a bunch of local services that are running in the process, right? So this kind of show the core concept Loopback have. It seems a little bit busy, but when you grow your project to certain scale and a certain complexity, you'll appreciate this separation of concerns. Then there's some infrastructure that glue these pieces together. So we have the so-called like a context, which is a container of these different pieces, right? Because now you have so many pieces, you need to have a meaningful way to discover them and resolve them. So the context is serving that registry. Then each entry in that registry becomes a binding. It's say, okay, for the given application context, I have this repo, I have this controller, I have this local service. So every single presentation will become a binding. Then when it comes to like A depends on B, say this controller depends on this service, right? Then we could have this dependency injection. So you just have to declare the dependency on the controller level. Then magically, the loopback runtime will find the right, dependency for you, and you just assume that instance is available to your code. You don't even have to do any lookup, right? Then because we are talking about this application, right? And imagine for the Collab.Land application, how many modules we have. And inside every single module, there's also tens of controllers and services, right? So just simply use one application might not be good enough. Then we have to break the application into smaller pieces called components. So components are more like a sub-application to help us organize the code so that we can group a bunch of services or group a bunch of controllers based upon the domain. And kind of going back to the CLI I'm showing here, right? So you can see, okay, there are a lot of different components we have. Components for Airtable, components for analytics, components for AWS, component for Disco, component for GCP, components for health check, components for the different blockchains, components for token claim, Telegram, web authentication, right? Those are a meaningful way to decompose a complex system and make it easy for them to be developed independently, right? So that's why, like, for the developers we have working on this gigantic mono repo, and we don't get lost because every single developer, they probably just want to focus one package or multiple packages at the same time. And that gives us that ability to scale the team as well. Right? And I also want to take this opportunity to walk you through some of the core concept we have. And I just want to give you some pointers. So this kind of illustrate the different concept, like at really, really top level. Every single loopback process as an application, right? Then inside the application, you can compose all the components into the application. So this diagram kind of shows you how that get glued together. And inside the component, you actually maintain some context. So this is application level context. Then you can have multiple components contribute to this application context. Then each component will becomes a container to all the pieces So we already mentioned we have controllers and some other things in Loopback, right? Then of course we need to maintain the life cycle. So when you start the application, you need to bootstrap certain things. When you shut down the application, you have to shut down certain applications. And this is a very simple way to register a component. So basically, you import the component, and then you just call app.component. So you kind of compose them into the system. And Loopback itself comes with a bunch of code components. For example, this component deal with the API Explorer, right? And we also have authentication and authorization component. Then we also see a bunch of extensions as function as an additional component coming into the system, and we maintain a lot of community extensions. Right. So this is a high-level fly-through of the different constructs you will see from the Loopback side. One more thing I want to show you is a tutorial that shows the ability of extending any Loopback application. So this is a series of tutorial to talk about how you can potentially leverage Loopback to build a very large scale Node.js project, right? And it gives you a really walkthrough. So first of all, we kind of describe the simple scenario, right? So this scenario is very simple. It's a fancy version of Hello World. So we have this grading service, and the difference is the grading service will grade depend on the incoming language expectation. If you want to get a grading in English, you get a grading in English. If you want to get a grading in Chinese, you get a grading in Chinese, right? And for this simple application, you can see we need to have this extensibility because depending on what language the browser tells us to use, we need to find the corresponding grader to produce the meaningful grading, right? So everything is in the open source. You can check out by yourself. Then here's a little bit talking about the architectural challenge. Then what comes to this solution, we incrementally introduce this different concept. So for example, the context is a key container to manage the registry, right? So this is the API we allows you to, register different pieces into the registry. Then you create a so-called grading application, and this grading application allows you to add additional services and even grab a component as a whole. So think about component as a group of services and other artifacts, right? So this allows you to assemble a loopback application either directly from the service, or you can actually grabbing a bunch of other services from a component, right? And Loopback even have a convention-based discovery to base upon the code base to discover the different artifacts and automatically register them to the system. Then on top of that, I want to briefly talk about this concept of dependency injection, right? So typically when you try to invoke A from B, you write a code in A and you kind of say, hey, let's create a new instance of B and invoke that B instance, right? That works well for simple project because you have the full visibility and the full knowledge about the dependency tree, right? But when it comes to a skill like us, we have 99 NPM modules and there are different services, and each service have different scoping because some service for the performance reason, you want to keep that as a singleton. For some services, you want to have additional context for every given HTTP request. That means you have to instantiate a service per request, right? So this complexity deserves to have a better way to handle that dependency. So that's where the dependency injection will come into place. So the traditional pattern is say, hey, we have to deal with the Chinese grader and the English grader. So we basically say, hey, let's create two graders and using them in the grading service, right? So this has some limitations because you have to know all the graders ahead of time. And you create a hot dependency on all these graders from the module perspective. Now, looking at a different way. So first of all, we use this dependency injection, and we use this so-called declaration. So declaration is adding some metadata to the class and say, hey, for this constructor, this is a traditional JavaScript TypeScript, right? Say I have a caching service, and I need to, get an instance of the caching service, and how do we meaning for this caching service into my cache observer, right? Then we say, okay, let's create a, caching interceptor, and we move these things into here, and this magic is enforced by Loopback, and Loopback will make an instance of the caching service available to you, depending on these declarations, right? So that's the starting point for the dependency injection. Then further extend the concept of dependency injection. In a lot of cases, you need to have this unknown extensibility. Imagine for the greeting service, which is a very simple service, right? So say you start with the English greeter and a Chinese greeter, but tomorrow you want to have a French greeter. How do you do that, right? So traditional way is you keep adding spaghetti code to the greeting service. Hey, if English do this, if Chinese do this, if French do this, right? But a better way is like you have this, registry, and this registry have knowledge about these two different parts, right? So for the extension point parts, it's the common logic that your upstream will depend on. Because, for example, for the greeting API, you only have to call the grid and tell the system which language you want to use, right? Then we need to have the ability to identify or discover which grader is suitable for what language, and then we directly invoke that one, right? It's a one-to-many dispatching pattern, right? So what implemented in Loopback, first of all, you define this common interface. Every single extension need to implement, right? Because that's the expectation from the extension point. Say, when I talk to an English grader, I need to call this grid function. And I also need to have a little bit of metadata to know which language that grader supports, right? Then we say, okay, let's create this greeting service. And this greeting service actually is an extension point, meaning you collect a bunch of graders into this service itself. And here we use a so-called get pattern because we solve these graders in a lazy fashion. So basically, we expose a function which allows you to get a list of graders. But we also have a flavor called extensions.list to give you the real instance right away. But in some cases, there might be circular dependency and other things. So we introduce this getter pattern for that purpose. Then another way is you can decorate the greeting service. Say, hey, I'm serving as an extension point. So that's kind of the Lego game, right? So you have one Lego with some of the male female connectors. Then you allow all the pieces to be plugged into this Lego piece, and you don't know all the Lego pieces ahead of time. So that's a critical requirement. Then now what do we have is say, hey, all of a sudden with this declaration, Loopback magically make all the graders available to this grading service. Then what a grading service have to do is try to figure out, okay, for any incoming request, we know the language from the HTTP request. Then we say, okay, let's look at all the graders we have and see which one can handle my language, right? Then I implement aggregate grid method, which takes the language and the name and say, okay, let's first find a grader, which is discover that extension. And if we find a corresponding grader, we just make a call to that grader method. So if happens the language is French here, we are going to create a French grader. And then we fall back to the English grader if we don't find any other graders, right? Then we also can implement and plug in the different graders as this fashion. Like say here we create a Chinese grader, right? So the Chinese grader implements this grader, and then we say, hey, this is an extension to the grader extension point. Then we say, okay, not only we can support that plugin, we can also allow configurations to be declared as well. So in this case, like different language have a different convention. For example, when it comes to the name, right? In the Chinese language, you usually start with a last name, then you do the first name, right? So this gives you a little bit flavor, like say for the Chinese language. And when it comes to grading, you just say, okay, you do like a name first, or you do like a hello first, right? So those are the pieces that really glue all the things together. Another interesting thing I want to show you is, hey, now I have a bunch of graders, right? How can I bundle all these graders into a component? So this way I create a component, and in the component we just register all the different services, right? And I show a couple of different ways to register things, and toward the end, we kind of say, okay, here's how the composition happens, right? So the additional things from here, for example, between the different pieces, right? For example, you want to do caching, then you want to intercept the traffic, right? Or you want to do authentication, you can intercept the traffic. Then again, also depend on the life cycle of the application. Right? Application can start, then you connect to the database, you connect to Redis, or you have a background timer. So these different things could be hooked up with a life cycle control. Then we want to separate the configuration from the system itself, either through the environment variables or through a configurable binding. So this kind of reflect the 12-factor application, right? Then there are also other things like you can just discover the different pieces by convention. Then we have a bunch of other recipes if you become sophisticated with Loopback. So I talked a lot about Loopback, and I want to go back to the Collab.Land side a little bit, and at least show you one or two pieces that utilize that pattern. So let's say we have this token gating capability from this asset manager service. And if you look at this asset manager service, so we have this asset management service, right? And if you look at here, they basically say, I want to get a list of all the different TGR authorizers. And this utilize this extension list, and this extension list give me the list of different access authorizers. So this is a common interface every single TGR implementation will have to implement, right? So from here, I don't see any other TGR implementations, but I get an injection of these different extensions. Then I also get injections of other things. For example, we want to access to the database. We want to have access to the job service. So those are the dependency injection happening here as well. Then kind of look at the access authorizer, right? So I can go into the pull-up, right? So pull-up contribute access authorizer. And if you look at here, especially for the main class, let's go down to the, So here we define a pull-up based authorizer. And you see some declaration here. Say, first of all, we are going to have a singleton. And we give this service a particular key. Then we have this magic say, oh, I'm creating a pull-up TGR, and I'm adding my contribution to this access authorizer extension point. This helps Collab.Land runtime and the Loopback framework to compose the pull-up service into that asset manager service, right? Then at component level, we also have this asset manager component, right? And the job of the component is basically listing the different artifacts. So we have a bunch of controllers which serve the REST APIs. Then we have a bunch of services, right? Then this component's responsibility is to create a local grouping of the different things. Like we adding a repository, we add another component. This handles a staking contract. Then we also register a bunch of blockchain connectors for NEAR, for Ethereum, for Solana, right? And this one basically say, hey, now we have this component, and this component contains so many things. Then this component will be composed into the application. So if we look at here and say, hey, let's see where the component is being used, right? So we could look up this application. So this is an API server, right? So this is our API server. And if you look at API server, it's a first tier composition, right? And we get this access manager component, and basically we register this component to the API application, right? So from top to the bottom, we have the application. So application can drag in a bunch of components, right? Now, if you go into the component itself, the component will collect a bunch of other artifacts, such as a controller, such as services, and all these things will meaningfully have the ability to get stitched together through the dependency injection. So this is another example of the dependency injection and the extension point pattern, right? So this is a ability to load the different NFTs and the fungible tokens from the different blockchains. So we have this common interface called asset loader, and we have this common interface called chain connector, and the chain connector will be contribute to this chain connector extension point. So we have Ethereum side, we have Solana side. Then this chain asset node service will be further composed into the asset manager service, right? So it's a multiple level of delegation, and sometimes it's a one-to-one delegation. So that will be easy as a dependency injection. Sometimes it's a one-to-many delegation. Then that's where the extension pattern come into play. All right, so I talk a lot, so I want to switch back to Discord side, and hopefully this give you a really quick walkthrough and how we leverage Loopback to really create a sophisticated backend that work at really, really large scale to handle a lot of traffic and handle a lot of integrations for Collab.Land itself. So give it a try and then let us know if you like it. And I want to keep the rest of 10 minutes for Q&A and pull up and some other fun stuff. Let's see if there's any questions on the chat.
Let's see. And yeah, that was a lot of information, but it's so cool to watch everything that happens behind the scenes. There's one question in the chat. Let's see. What do you see? And this is from Wei. Question for the seminar. What do you see Loopback going forward?
Yeah, so that's a great question. Like, if you look at the overall picture of Loopback, right, and we have been developing Loopback in open source for more than 10 years, and it's still ongoing. So I think Loopback can still function as a fundamental piece to how TypeScript developers to compose. So if you look at the different tiers we have on Loopback, so the core tier is like a mini container, and that container can guide you to create a larger scale project that involves a lot of modules and a lot of pieces, and adopt the well-known pattern like a dependency injection and the extension point to make your life easy, to maintain that level of complexity. The second tier is all the integration capabilities, right? So we have the REST API implemented out of the box. We have connectivity to a lot of well-known services as well as a lot of popular databases, right? So those will serve as a go-to place. And we also integrate with other ORMs such as Type ORM to make it easy. Then we have this ability to extend the loopback itself by contributing extensions either to the framework or to your application directly. So that keeps the door open. So we try to achieve this balance of like 80-20 rule. Like 80% of the case are repetitive case, then you can just use the abstraction we already built, right? Then for the 20% of the advanced use cases, we give you the pattern, we give you the pluggability so that you can meaningfully extend your system to do the way you want to do and make sure the system will function in the way as you expect it. Any other questions?
All right, we got a thank you from Wei, and thank you, Wei, for asking that question. Let's see, and let's mention to everyone in the audience if you guys have Any other questions, please feel free to write them in the chat, or you can raise your hand if you would like to be brought up to the stage. Any of those would be perfect to ask your questions. And in the meantime, I think that we can get to the POAP distribution. What do you think, Raymond?
Yeah, I think that's a great idea.
All right, so I'm checking real quick that it's all set up and ready to be claimed. Yes, okay, so for you guys, if you would like to claim today's Dev Deep Dives POAP, we will be using the POAP mini app as always to claim this POAP, and that's with the slash command slash POAP claim. That will ask you for a claim phrase, and this POAP claim phrase is loop back, all lowercase and with no spaces in between. Again, that would be loop back. Once that you write that down, you can hit enter and you'll receive a code to claim your POAP. Once again, just in case that anyone missed it, we're using the POAP mini app, so that's with the slash command slash POAP claim. And I'm also sending the command in the state chat, so you can click that and it should work. And then the claim phrase for today's POAP is loop back. So that would be LOOPBACK, loop back. Please let us know in the chat if you were able to claim successfully. Otherwise, I can get you guys a code to claim your POAP if there's any issues with claiming. Right. It worked for Ayotunde. Thank you so much. Claiming mine too right now. And I think in the future it'd be cool, Raymond, to do like a raffle for all of the attendees that have collected these POAPs. So we can start thinking about that. Maybe give out some merch, or I don't know. We can think of other rewards to make a raffle. I think that'd be really cool. Oh. And this is Ayotunde's 54th POAP from Collab.Land. I think that's so cool.
That's fantastic. Thank you for sticking
Right?
with us.
Yeah, appreciate you so much. And appreciate everyone joining our events. It makes my heart really happy, so thank you. Oh, love to have you here. All right, I think there's no more questions, but for everyone in the audience, if you happen to have any questions in the future that you would like to ask Raymond, please feel free to write those in Dev General. I think that's the best channel to ask your questions async, and Raymond will gladly assist you with those just for the future. Yeah, other than that, I believe there's no more questions, so we should be good to wrap things up.
Yeah, thank you so much, and see you next time.
See you guys next time, and thank you, Raymond, for this amazing session of Dev Deep Dives. Thanks, everyone in the audience as well. We'll see you guys next time. Bye bye. Oh, also a quick reminder, we have Twitter Spaces tomorrow. And we want to invite you guys if you want to join the panel to speak in tomorrow's Twitter Spaces. Please let us know because we would love to have you there. It's gonna be about hot topics and kind of an open conversation. So if you're interested, please let us know. I will drop the link in the stage chat for the event. But yeah, that's about it. We're gonna have Ayatollah joining, which is very exciting. But yeah, if anyone else wants to join or can join, please let us know. We would love to have you there. Oh, and yeah, for my god, this was recorded. Oh, yeah, I see you in the audience. Yes, this was recorded. It will be posted on YouTube. So you can check the recordings channel. We'll post it in there once that it's ready and out. But yeah, see you guys next time. Thanks again for joining. Bye bye.